So, good afternoon, everybody, and welcome to Week 5 NPTEL Previous Year Assignment Question Solving Section. I am Suraj from Chemical Engineering Department, IIT Kharagpur. So, the first question is flooding is identified by a sharp dash in column pressure and pressure drop and significant dash in separation efficiency. So, can you please tell what will happen if to efficiency of the separation if flooding happens, whether it will increase or decrease? Hello. Okay. Hello, please unmute and can you tell the answer for this if you can?
Yes, sir, 1 second.
So the pressure drop will increase and efficiency will decrease if flooding happens. And answer A, yes, that is true. Answer A is true. So we need to know what is flooding. The flooding is a phenomena which will occur when the flow rate of the vapor and liquid are such that the liquid can no longer flow down the column through the sieves. So there are mainly two mechanisms for flooding to happen. First one is when excessive entrainment of up the column with the vapor happens, and second one when the downcomer is no longer able to allow the liquid to flow at the required flow rate. So next question, for determination of bubble cap tray diameter, the Sauder and Brown method is based on dash, whereas Fair and Matthews method is based on dash. So before that, we need to see what are the main parameters for like active tray area, net tray area, and other thing. If A is the total cross section area and ADC is the downcomer area, then active area AA is given by total cross section area minus 2 into downcomer area, and net tray area is given by A minus downcomer area. A is the total cross section area. Uh, the tower diameter can be estimated mainly by using two methods. One is Sauder Brown's method and second one is Fair Matthews method. In the first method, the tray diameter is obtained by assuming the vapor flow rate, mass flow rate of the vapor as mv and maximum allowable mass flux is mv max. Then the tray diameter is given by this equation where mv max is determined by c into c multiplied by square root of density of vapor into density of liquid minus density of vapor, and this c is a function of surface tension of the liquid and tray spacing. So after finding mv max from here, we will substitute it in this equation to obtain tray tower diameter, and this mv max is based on total tower area. This mv max is vapor mass flux. It's based on the total tower area. The second one is Fair and Matthews. Then it's a correlation of flooding in the bubble cap trace to estimate the tower diameter, and it's a graphical relationship which correlate the flow parameter FLV and vapor capacity parameter CSB. Then here the flooding condition is based on net tray area, but in Sauder Brown's method it is based on total tower area. So can you tell the answer for this for determination of bubble cap tray diameter? The Sauder's and Brown method is based on dash, whereas Fair and Matthews method is based on dash. Hello.
Option D.
Option D, yes. Thank you. Then next question. Here a sieve tower is given, and the liquid flow rate ml and vapor flow rate mv is given. The liquid flow rate is 1400 kilogram per hour and vapor is 1800 kilogram per hour. Then we need to estimate the liquid vapor flow parameter FLV and flooding velocity for the following inputs, where density of the liquid, density of vapor, and surface tension, trace spacing, and K1 is given. So can you see the whiteboard?
Yes, sir.
Okay, thank you. Then uh, first of all, first we need to find the FLV. FLV is the liquid vapor flow parameter. This FLV is given by a equation. FL, FLV equal to mass flow rate of liquid by mass flow rate of vapor into square root of density of vapor by density of liquid. Here, mass flow rate of liquid is given as 1400. Mass flow rate of vapor is given as 1800. Then density of vapor is 3.2025. Density of liquid is 867. So after substituting, we will get 1000. So can you please calculate this value and tell what will be the answer for FLV? Hello.
0.047259.
Yes, yes, 0.0472. Yes. Then, then they have also asked us to find flooding velocity for the below conditions. So the we know that the 0.047 is got. So the option will be B. So we need to find flooding velocity also to check whether it is matching with it or not. A flooding velocity is given by UFV UFVN. Then the equation for flooding velocity is this is the equation for flooding velocity k1 corrected into square root of density of liquid minus density of vapor by density of vapor. This k1 corrected can be found out from surface tension and k1 value. This is the equation for k1 corrected. K1 corrected equal to k1 into sigma by 20 raised to 0.2, where sigma is the surface tension. Uh, Surface tension they are given as 28.25 dyne per centimeter. And the K1 is given as 0.088. So on substituting this value, we will get K1 equal to K1 corrected equal to what is the can you calculate this K1 corrected? What have you obtained? Uh,
0.09429.
Actually, sorry, this K1 value is 0.082. K1 value is 0.082. So uh, on substituting this, I'm getting as 0.088 K1 corrected. So then afterwards we need to submit this 0.088 in the above equation for flooding velocity. So can you calculate this value for flooding velocity? K1 we have substituted, then rho L from the problem they have given rho L and rho V. So what is the UFN?
1.44.
Yes, 1.445. Thank you. So the flooding velocity is 1.44 and flow parameter FLV is 0.042. So answer will be option B. Then next question. In trace, a calming zone is provided before the outlet wear to uh, calming zone is given before the outlet wear. Why is it given? Can you tell? Actually, the calming zone will allow the of entrained vapor from the liquid. This is if this is a tray layout. In a tray, there are two calming zones. One just before the outlet wear and just before the inlet wear. So this is the calming zone. This one and this one. So this is provided to release the entrained vapor from the liquid. Next question. In a distillation column with cross flow sieve trays, entrainment flooding occurs with increase in dash velocity and downcomer flooding occurs with increase in dash velocity. So let's just see the details. There are two types of flooding. One is entrainment flooding and second one is downcomer flooding. This entrainment flooding happens when the vapor entrain a significant amount of liquid along with it, which is mainly due to the increase in vapor velocity through the sieve. Next one is the downcomer flooding, which is due to the increase in liquid velocity. And the with increase in liquid velocity, the height of the downcomer backup will increase. This will cause the downcomer flooding. So here they have asked by which mode entrainment flooding is occurring. What is the reason for entrainment flooding? Vapor or liquid?
Vapor.
Okay, and for downcomer flooding, it is liquid. So the answer will be option A. Option A. You got it, no? Then next question. Choose the incorrect option among the following. Splash baffles are used for vapor liquid disengagement at outlet of the tray. Diameter of distillation column is decided based on whipping condition. Next one is advantages of tapered downcomer is to twofold, as top portion favors vapor liquid disengagement and narrow bottom portion ensures sufficient liquid backup in the downcomer. So which one is the wrong answer?
Option A.
Option A. Uh, Option A and C are correct, but option B is wrong. Here, option B, they have told that the diameter of distillation column is decided based on weeping condition. So, when weeping happens, is that when the liquid flow rate is high, and so that liquid will be weeping through the pores of the tray. So, that is the condition of weeping. Actually, we are finding the diameter of the column using flooding condition. Uh, Previously, we have seen the liquid flow parameter FLV and flooding velocity. This flooding velocity is used for finding the diameter of the column. As diameter and area related, diameter and total flow rate are related. So how diameter and total flow rate are related? If total flow rate is in meter cube per second and diameter is in meter, then how they are related? How can I find the diameter from total flow rate? And velocity is also given. We can divide the total flow rate with velocity to obtain the diameter. First we will find the area, then from there we can find the diameter. So diameter of a distillation column is based on flooding condition, not on weeping condition. Next one, match column 1 cause and column 2 effect in the case of sieve tray design. Column 1 increase in perforated area can you match this and tell the answer?
Three.
Option D. Option D is the answer. Like with increase in the perforated area, the vapor will decrease and liquid weeping through the perforation will decrease. So with increase in A is 3, and next one is if the downcomer area is reduced, the active area for vapor liquid contacting will increase. So B is 4. Then the next one is if the liquid flow length increase, then hydraulic gradient will be higher. So C is 2 and D is 1. The next one, in a distillation column with sieve trays, H1 and H2 refer to the height of the liquid at the inlet and exit of the tray. If H1 minus H2 is unacceptably high, a suitable tray type to replace sieve trays may be. Hello? Okay. Do you know the answer?
Sorry, sir. No idea.
If the difference in liquid height at the inlet and exit of the tray is high, then there are two options of tray. Once either we can use split flow tray or stepped tray. So the answer will be option C, both split flow tray and stepped tray. Next one, height of tower depends on number of actual trays and tray spacing. Height of back tower depends on number of theoretical trays and HETP. So which of the statement is true? Statement 2, which one is true?
Option D. Both statements are true.
Both statements are true. Yes. Actually, the for packed tower, we'll find the HTTP value and number of theoretical plates. Then how can we find the height of packed tower from number of theoretical trays and HTTP?
By using efficiency, overall efficiency.
Yes. Then afterwards, how can we find if we got HTTP and number of theoretical trays? Then what will be the total bed height of packed tower?
So we multiply them.
Yes. Multiply product of number of theoretical trays and HTTP. And in the case of tray tower, it will be the product of tray spacing and number of actual trays. So from where can we obtain the number of actual trays? can we use for finding number of actual?
Make-up theory method.
Yes, make-up theory method. So both 1 and 2 are true. So next question, choose the incorrect statement among the following. Very low downcomer backup reduces tray efficiency. Structured packing provides a higher pressure drop compared to random packing. Structured packing provides a higher specific surface area compared to random packing. Packed tower is provided with liquid distributor to make the liquid flow uniform. So which option is incorrect?
Option B.
Option B.
Yes, sir.
Yes, option B is incorrect because can you tell the answer why? What is the main difference between random packing and structured packing?
In random packing, we simply put all the packing materials randomly. Means we don't arrange them in orderly manner.
Yes, okay. So the structured packing will have higher pressure drop or lower pressure drop when compared to random packing.
Sir, because it is uniform, so we know how much amount of pressure drop will be occurring to structured packing.
Okay. Okay. So the pressure drop will be lower in case of structured packing, and it will have high specific surface area. So here they have written the pressure drop is higher. So option B is incorrect. Thank you for listening.
Thank you, sir.
If you have any query, you can ask.
No query, sir. Thank you.
Okay, welcome. I'm leaving the meeting.
Yes, sir.
Okay, thank you.